You're welcome to today's video lesson. Okay, this is the WAEC Physics 2021 Electricity Practical Cheat. I have already made a video on the practical itself. This is the cheat. Ways to outsmart the practical without doing little or no stuff. You can pause the video and take a good look at the questions. Okay, now we are going to move further into ways by which we can outsmart this practical. Now, for us to be able to outsmart this practical, what are we supposed to do? We need to find out the theoretical principle behind it. Very, very important. Now, remember that there's a relationship between the resistance of a wire and its length. And we can show this relationship with the formula resistance is equal to rho L over A, where R is the resistance of the wire, rho is the resistivity, L is the length of the wire, and A is the cross-sectional area of the wire. Now, so the Constantine wire and the crocodile clip, they are acting as a variable resistor and is connected in parallel to the 2 ohm resistor. Connected in parallel. Okay? Now, we are going to perform the experiment while the crocodile clip doesn't touch the Constantine wire, and in doing that we got that the EMF of our battery is 2.4 volts and the current while the crocodile clip wasn't touching is 0.66 ampere. These results we are gotten from my previous practical I performed. So with these values now we are going to find the internal resistance of the battery using the formula shown. Okay, the capital E is the EMF of the battery, I is the current, R is the external resistor, that's the 2 ohms resistor, and small r is the internal resistance of the battery. So with this formula, we are going to substitute these values we have to find the internal resistance of the battery. Very, very important. So evaluating for the internal resistance of the battery and substituting the values where necessary and simplifying, we have that the internal resistance of the battery is 1.64 ohms. So we take it down. It is very important and we'll be using it. Alright. So the resistance of the wire when the length is 90 cm. So we now perform the first experiment because we need to perform the first values of the experiment to get this thing. So from the first values of the experiment, when the distance is 90 cm, the current flowing is what? 1.08 amperes. Okay, so if the current of 1.08 amperes flows in the circuit, we can now find the resistance of the Constantine wire as follows. Okay, using this diagram will be our guide. All right, the R there is the resistance of the Constantine wire in parallel with the 2 ohms resistor. Okay, and we are going to use this formula. E is equals to I open brackets the total resistance plus the internal resistance of the battery. Okay, RT is the combined resistance of the circuit, and when we substitute where necessary, we will have that the combined resistance is what? 0.58 ohms. But we know that 1 over R total is equals to 1 over 2 plus 1 over R. That R is the resistance of the Constantine wire. Don't forget that. Alright, so simplifying to find the resistance of the Constantine wire, we will have that the resistance of the Constantine wire is what? 0.82 ohms. Very, very important. So we take note of that. The resistance of the Constantine wire is 0.82 ohms when the length is 90 cm. So we are not done yet because we need to get some things straight. There are other things we need. Now we've gotten the resistance of the Constantine wire when its length is 90 cm. There is one more thing that's left to do, and what is that? Okay, we have to use this formula, this relationship, to get a constant. Okay, the formula that relates the resistance and the length of the Constantine wire, we need to find a constant there, and that constant is rho all over the area. You know, the area is constant as well. So that's constant. Simplifying to what we have, the resistance is what? 0.82, and when the length is 90, simplifying it, I have 0.0091 ohm per cm. This is very important. We've gotten all we need. So let's go ahead now. So when the current in the circuit is, so what will be the current in the circuit when the length is what? 80 cm. So when the length is 80 cm, using this relationship, very important, and we know already that the constant rho over A is what 0.009 ohm per cm. So we just make quick substitutions. So the resistance at 80 cm will be what? 0.0091 times 80, and that will give us 0.728 ohms. So remember, this diagram is very important. So that is the resistance of the Constantine wire. So we have to find the total resistance of the circuit, and this is a resistance in parallel. So the total resistance in parallel is what? 0.534 ohms. So solving for current, we simply use this formula, what? E is equals to I, open bracket, R total plus the internal resistance, and simplifying where necessary, the current now is what? 1.10 ampere. Okay, so that's the current when the length of the resistance is what? 80. Now what is the current when the value of the Constantine wire is 70 cm? So still using the same procedure, we have to find the resistance of the Constantine wire at length 70 cm. Okay, and using the same procedure I've stated earlier, I'm making substitutions where necessary. The resistance of the Constantine wire is what? 0.637 ohms. Using the same diagram, okay, the resistance of the Constantine wire and the 2 ohm resistors are in parallel, so we need to find the combined resistance. So finding the combined resistance using the formula shown, okay, and simplifying everything, I have was 0.483 ohms. So we have to substitute these values and find the current in the circuit. So the current in the circuit will be gotten using this relationship again. I'm making substitutions and evaluating for I. We have that the current is what? 1.13 ampere. Now, what is the current in the circuit when the length is was 60 cm? So when the length is 60 cm, we recall the relationship and we just make quick substitutions just as we've done in the previous two examples. Okay, so the resistance of the Constantine wire at length 60 cm will be 0.546 ohms. So we've gotten that. We'll still use this diagram as our guide. We have to find the total combined resistance for the parallel connection, which we have 1 over R total is equals to 1 over 2 ohms plus 1 over 0.546 ohms. So simplifying, we have that R total is equals to 0.492 ohms. So using that formula, that EMF is equal to current, open bracket, the total resistance in the circuit plus the internal resistance of the battery. I'm making substitutions where necessary and solving for the current in the circuit. We have that the current is what? 1.16 amperes. So we take that down. The same procedure goes for when the length of the Constantine wire is 50 cm. So we take the same steps. Okay, the same steps are taken. So we find the resistance of the Constantine wire at length 50 cm, and when we do that, the resistance of the wire at length 50 cm will be 0.0091 times 50, which is what? 0.455 ohms. Okay, so using the diagram again, so we are going to find the combined resistance of the circuit shown. So we have that the 1 over R total is equal to 1 over 2 ohms plus 1 over 0.455. Simplifying, the total combined resistance of the parallel arrangement will be 0.371 ohms. So we have to solve for the current in the circuit, okay, with the same formula as stated. Solving for the current in the circuit, substituting the values where necessary, we have that the current in the circuit is what? 1.19 ampere. All right, so this is how we can be able to outsmart this practical. That's the brain behind this practical. All right, so we are going to compare the table of values, okay, of the practical performed real life and that of the cheat. So this is the table of values for the cheat, okay, and you're going to see the table of values for the normal experiment, okay, performed, which I have done previously. All right, so we can see that there's a little difference, but there is similarities in the sense that the trend that current increases as the distance decreases. Okay, the current increases. That's just the thing. Okay, the current increases as the distance or the length of the Constantine wire decreases. Okay, so we now go to the graph plotting. We are going to plot the graph of I against the inverse. All right, so the scale is still the same thing, 2 cm to represent 0.5 units on the vertical axis and 1 cm to represent 0.0025 units on the horizontal axis. So we plot the points. Okay, when d inverse is 0.011, current is 1.08, we mark out the point. So when d inverse is 0.0125, the current is 1.1, we mark out the points. When d inverse is 0.0143 per cm, the current is 1.13, we mark out the points. When d inverse is 0.0167 per cm, the current is what? 1.16 ampere. And lastly, when d inverse is 0.02 per cm, the current is 1.19. We mark out the points. So we now join with a very straight line. Okay, that's the graph. You join the points to form a perfect straight line graph, as you can see, with an intercept on the vertical axis. So the slope, we take 2 points, 2 convenient points for us from the graph, and form a convenient right angle triangle. So the slope is simply going to be the change in current all over change in the inverse. Okay, so it's not going to be the 2 points I chose is 1.19 minus 0.93 divided by 0.02 minus 0, and simplifying gives me 0.26 divided by 0.032, which is what? 13 ampere cm. So our slope is 13 ampere cm, and the intercept on the vertical axis is 0.93 amperes. All right, so there are other things we are asked to simplify from the graph. Okay, which is what? C over S. So simplifying that, we have it to be 0.07 per cm. Remember, it is per cm in the sense that current will cancel out, sorry, ampere will cancel out ampere. So we will just be left with what? Per cm. Then we are asked to evaluate the value for the current when the distance d is 55 cm. And when the distance d is 55 cm, the inverse of d will be what? 0.0182. And from the graph, we read it off. And when we read it off to the vertical axis, we have the value to be what? 1.17 ampere approximately.